Hi, gents, hi, ladies. Very happy to be here with you in this evening. Hopefully, this 30 minutes will bring something new to your baggage of knowledge. But beforehand, let me present myself. My name is Tom. I'm working as a freelancer, but on an everyday basis, I had to work or maintain quite a number of Gradle scripts and builds. And I've learned some things I would like to share with you in the domain of the developing Android Gradle plugins. Before I will continue with the presentation, I would like to learn your experience. How many of you ever developed a Gradle plugin? Okay, a few hands, but it will be then more introductory and slash some new things that to take a careful look. If there would be time, we can go in the deeper topics, but we will see. So as a case study, I've decided to pick up something not that complex, but not that primitive as the Hello World application. We are going today to explore developing the plugin that allows us to essentially enable man-in-the-middle attack. That's what would be the most well-known, but taking away the Porsche words, we can call it simply allowing proxying tooling on our builds, not only debug, but release builds as well. For the timeline, this is known as a network security config property, which was introduced in 2016 and allows optionally on the device to declare trusted certificate authorities and enable, disable clear text reads per domain. But starting from 2018, this became out of the box. The clear text traffic no longer allowed. You no longer can easily attach stuff like Charles proxy or MeetM proxy or any other proxy network debugging tool. And here's another small detour. How many of you used this type of tools in your everyday practice? Few hands. For those who is not aware of what I'm speaking about, it's essentially another software that you can rely on to see what kind of network calls coming out of your application. You can still use from Android Studio, but if you're used to rely on something that comes from another software, which in my case was Charles proxy, you would need to follow the steps I'm going to describe here on how to enable it. And everything starts, as always in the Android world, with throwing yet another XML file, throwing some configuration, which is more or less approachable because they keep the domain language more or less clear. As we can see here on this example, the network security config file would essentially contain of parts related to trusting user installed certificate authorities, as well as keeping up trusting the system one and allowing clear text traffic per specific domain. So why the certificate authorities is important? We need to essentially tell our application that the certificate which our proxy tools give to us, it's simply a file that you would get out of your proxy provider, throw it on your device, install it from the shell, the one that you use. And it will install globally on your device. It doesn't mean that every application now can be sniffed through the proxy tool, and that's okay. But for the application that we are working on, this is our goal, is to see what is happening with the application when we are interacting it. It can be very useful if you're joining some project and you're not aware how the API works and you want to see how things flying in the real time. And if you're developing some features not only on mobile but full stack, you would most likely run something on localhost, on simple HTTP protocol, and you need to allow things going transparent. So this is not for us to hack the system for the bad purpose, but to hack the system for the case of getting more out of what is happening at the runtime. But usually what you would like to avoid is to enabling or disabling security features. Doing this by hand, okay, if you want to do it quickly, but if you need to repeat it all over again and again, it can become error prone. You can forget to remove it. You can push it to the version control. If you have a team, they might notice, someone might not notice, especially today when the code slope happening and there are so many things flying into the version control because of the introduction of IE. That could be another security risk. And to achieve this goal, we will rely on the Gradle plugin system to first generate this configuration file and then inject it and connect it safely to the Gradle runtime. So the most obvious thing coming to your mind when you're implementing any type of feature, any type of code, is how to prove that it works. And the second, how it continues to work after the many weeks, months of maintaining it. And the most obvious answer is to come up with writing the test. But before we jump on looking how the test would be organized, I will take a brief look on the high-level picture. So we will start with implementing a custom plugin named Android Metadata. It could be my plugin, whatever, which would look for the appearance of ComAndroid application plugin identifiers. All the plugins in the Gradle ecosystem has a type of identifier that you would put in your plugins block. And then we will safely react on new variant introduction. Variant is a combination of product, flavor, and build type. Essentially, you can build debug, application, release. This is the most simple two variant types. And we generate network security config task, completely up to us how to name it. And another is for appending this based on the merge manifest that Android Gradle plugin gives us. So here you can see the pipeline. You will notice that network security config task doesn't take any inputs, but outputs things. And in our case, it does output the network security config and registers it under custom resource folder. We are relying on the Android Gradle API surface. We don't care about how those resources get registered, but we need to tell it to do that. Otherwise, it won't end up in your APK Android package or Android bundle. With append manifest config task, situation is more trickier because we need to request the manifest from somewhere. And again, Android Gradle plugin will give us. We will transform it and output it forward. So we're essentially adding extra step into the pipeline of manifest transformation. Manifest transformation, fancy name, but essentially is grab this XML, add something, merge it with yet another XML from another module. And however complex project is, you don't need to care about this. And this is the beauty of the Android Gradle plugin public surface API. For the testing the project, we can reverse to two practices, writing simple tests, simple unit tests, but they are more about small modules or units. We are more interested in going through end-to-end testing. And for that, in reality, what we will do, we will scaffold the bare minimum project with 4 files. We will write in each and every file the most basic Gradle syntaxes for any dummy project you can imagine, with a small caveat that the local properties is not coming, usually it gets generated for us, and we also need to get it generated. This is an important moment that I will speak more lightly. In addition to having this scaffold project created for us, we would need to grab plugin version from our source code and expose it as system property. And yet another interesting part is that we are not simply letting the things get compiled, but also built, packaged as Java artifact jar, and then published to the Maven local. And for the sake of testing, I picked up JUnit 5. That's the scaffolding will happen before each callback for every file. To make things work for the long running, you would need to have cross-version testing also set up. This is very important because Android Gradle plugin evolves very rapidly, and things can break as a result very rapidly, especially if you have a complex configuration. And knowing that you have tested combination of both Gradle version and Android Gradle plugin, you will have some peace of mind in everyday life. So for parameterization, I've decided to pick up also GUnit 5 parameterized test annotation. And the key task we want to focus on is assemble debug, because this fires the whole chain, builds everything, and provides us the build. Plus, as an extra, to be a good citizen of the plugin community, you would need to support extra features, and the latest known feature is a configuration cache that allows to speed up the startup of the Gradle. So we will also discuss two major challenges, but now that we have a high-level perspective or picture, I will jump back to the source codes and showcase the things I've been speaking so far. So the most important part here is this folder called build logic. You can call it whatever you want. This is a classic monorepo setup. I'm keeping both production logic under the app, and then the logic of your custom plugin will live under this folder. You can name it as the way you want it. You can name it my custom plugin. I picked up build logic, and in order for this to work, we need to instruct in the settings Gradle file that include build needs to look for the project from on the root named build logic. In other way, it's to say the Gradle, please build this folder first, and then build up after that. As you can see, the build logic on its own is fully fledged project, which has its own custom module called Android. This is a custom name. I could pick Android whatever, but I kept up picking the most obvious one. The nice thing of this setup that you can cross-reference library versions. So whatever Android Gradle plugin you use in production can be also shared with your build logic in the monorepo setup. And now let's explore the plugin setup on the build Gradle file. So the first things we would need to make sure the Java Gradle plugin applied, and this is tells specifically where to look for the entry point. So any Gradle plugin in the end is just a jar, and in jar usually you would have a main function as entry point. With Gradle, you need an extra step. You need to generate the properties file and put a fully qualified name where this entry point lives. In order to avoid doing this on your own, you can achieve the same goal with simply importing Java Gradle plugin, which is coming out of the Gradle API surface. Maybe it sounds confusing to some of you, so I will say Android Gradle plugin as AGP forward, and this coming from Google. Gradle coming from Gradle. So don't confuse these two. Gradle is a build system. Android Gradle plugin is just yet another plugin, but we rely heavily it for developing Android applications or Kotlin multi-platform. This is also true for that case as well. We will define the artifacts for our plugin, version, make sure that all the dependencies configured. Oops. And for testing, we will simply tell this that we are interested in relying on the using GUnit 5 features. And the last piece is we are also relying on Gradle TestKit APIs. So Kotlin DSL essentially give us this syntactic sugar. JVM test suite give us this DSL, and Maven publishing is important for us to ensure that for every test run, we are also packaging stuff and publish it to the Gradle on your home root path. And here comes the plugin version mentioned on the slides that we simply expose as a system property, which is available on the test task API surface. This is pretty basic stuff. If you open any Gradle documentation, you would be able to see all this information, except maybe depends on, because this is the only thing I'm bringing to this presentation. Now let's quickly take a look on the implementation. So as you remember, we have to provide a fully qualified path, which is essentially points to this class, which implements plugin, and the target is a project. Project give us ability to call back into appearance or react on appearance of this specific identifier. And as soon as this block gets executed, we can start linking into the application Android component extension, which is pretty long way to say, but in reality, behind the scenes, everything gets delegated to as simple as this statement, which you're most likely used to seeing in the any Android code base. There is a small caveat. This is the second major reiteration of the AGP, and it comes. You wouldn't be easily reference it if you start looking for the on variants block. If you will try to type it here, it will be highlighted as red. But behind the scene, it will try to resolve the proper extension for us. This is something that, unfortunately, you need to read from the Android Gradle plugin public webpage. And this might not seem as obvious at the first time. But if you want to make the best out of the most modern APIs, I would suggest to rely on this type of extension. And here comes the callback that gives us variant. So this would be either debug or release in most basic setup. We are also adding ability to enable proxy or disable it at the build time. And here you would see that we are also ensuring that for every new variant, we would generate our unique task. We are doing this mostly because this ensures that your plugin doesn't conflict. You don't create a conflict on the graph tree, depending on the variant that you're building, either debug or release. There might be small differences, up to you, but this one specifically ensuring that the task, we either skip it or we either run it. And remember me speaking about connecting this stuff to the Android build process. This is where you essentially tell, hey, here is my task. Here is the resource directory that this task outputs. And it will appear naturally for you. It will be registered. You don't need to care about that part. The only thing is just to mention this in your build configuration. For wiring artifacts, which is a little bit more complex, but essentially we are transforming manifest, we need to get it from somewhere. So this line will tell it, grab it and put it into the merge manifest property. This one would be this property we are outputting, grab it and continue the preprocessing. Quick sneak peek in the implementation of both tasks, and we can move to the tests. So as you can see, there is no rocket science. We create XML directory, and then we put a multi-line string with the same XML being showing before. And appending manifest might at first look intimidating, but this verbosity coming out of the fact that I've used Java XML. If you used to use any other serialization framework, you can pick it. I just picked something out of the box. Essentially, the one is looking for the attribute in your manifest called Android Network Security, removing it, and then resetting with the new one we are interested in. So this is implementation detail that's not that important. Important the fact that we are essentially parsing XML tree, loading its model, modifying and returning back to the new manifest file. Oops. I just realized I don't have mouse. I'm a little bit struggling here. I don't know why it disappears, but with the GUnit 5, you can essentially put annotation and request a temporary directory. It will go a /temp folder. and give it back for you. You will populate this scaffold project with the same information you would see in the most basic project setup. The only difference is that we are telling that first look on the Maven local, because it's where we're gonna publish our artifact. And publishing our artifact this way, we will go through the natural resolution of the plugin path. So whenever you use any plugin, the one gets first pulled from Maven, unpackaged, and then loaded in the class path. And this is what we are trying to simulate here. We are doing we are keeping our test setup as close as it's happening in the production, instead of simply relying on something called with plugin class path. Manifest is very basic here. And the Gradle file, the root one, would come with a Android application, its specific version. And here comes our custom plugin here. This is the identifier. We have declared it as an ID in this DSL. And now we can simply issue this plugin from the local Maven setup, supplying the plugin version. Again, the plugin version came outside here and defined here. It's up to discussion which approach is better. Someone would read from file or any other provider type, but this is for the simplicity kept hard-coded in the code base. The test itself, pretty straightforward. We are finishing writing all the necessary files, importing GradleRunner, and this is the part coming from the Gradle TestKit. We are providing the path to the project directory. We are picking up the Gradle version, and then we are firing assemble debug with our flag enabled, and for the extra information with the stack trace. We are forwarding output, and after that we are looking if the task succeeded or not. The beauty of this approach is that we can also test for another extra features, the one mentioned as a configuration cache. And this essentially not that far away from simple unit testing. You give something, you modify it, you assert that output is the way how you expect it to be. And you no longer have doubts that it's working, because we actually created project from scratch, throw our plugin there, executed the task, and ensured that those side effects we were encoding in our code base are still sound and running. So, getting back, this section about the with plugin class path, if I will copy it, you will see that this is just a line of code available on the surface of the GradleRunner. And this line tells, grab this code here, and instead of packaging as Java artifact, link it to the runtime class path. Any Java application has the idea of building long string of jars as the dependencies, so that when you run your bytecode, it actually knows where this library is coming from. And the with plugin class path is a way to say it actually lives here in this source folder. We are skipping this line here. We are doing the full simulation of real world with actually consuming our artifact. And in addition, if you take a careful look, it says compile only, but then how it runs. And because compile only guarantees that code will compile, but then when actually it will be executed, it won't be able to reach Android Gradle plugin because it has no transitive dependency. And this might seem counterintuitive and wrong, because you will get no class defined error, string will blow up in the runtime. But in reality, we are making assumption here that all the projects, whatever project you will join, will first declare Android application plugin here. And this is way, by opting out from the transitive dependency, there is no way that we can bring our specific version into the client's code base, because this is where the source of truth is happening. We are only relying on the Surface API, and the things is not broken. We know that it's not broken because we test every possible combination that we are, of course, interested in. If you are not publishing plugins, and that's an important piece of notion, you can simply keep up using with plugin class path and simply using implementation here. Everything I said only matters if you're producing plugins for the outer audience. If you have a monorepo setup, which I've started my talk with, you can still reserve to using implementation. You have simpler setup and easier to reason about this. And this is also the line of code that you will find in the official Gradle documentation. So this is what I was highlighting. We are essentially letting our consumer to pick the Gradle version. We don't polluting their build class path, imagining the plugin developed for Android Gradle plugin 9th version, but then the customers still use the 8th version and there are breaking changes. And we want to make our life harder for consumers of our plugins. The plugin injects the runtime class path directly into test build, so you don't need to care about that if you're relying on the monorepo setup. This part already been shown by me. It's essentially what we did in the code by parameterizing, but I've simplified it, simply hard coding values here. And we are trying to pull things from the Maven local this way. So this plugins block, it looks like a magic, but in reality, it just loads separate software that will pull this artifact, unpack it, and add it to the build run commands at the runtime. So again, here is the picture of how to decide whether to use include build or skip it. You either ask yourself, will you publish it? If you know, then go with implementation plus with plugin class path, simpler setup. If no, if you want to publish it, you need to do that. You need to rely on the compile only and then publish to Maven local to get the full picture to test it in reality. SDK location was yet another interesting finding. Whenever you mess with packaging of resources, inevitably the Android AGP plugin will bring Android asset packaging tool. And this thing lives as separate binary in Android SDK. So whenever you work with a freshly installed environment, you would first install SDK, where we'll hold different build tools, and the Gradle plugin doesn't know where it actually exists. These local properties files automated for you during the project creation. Here is the mine, and it's usually excluded from the git ignore. We are scaffolding the real project, so we need to make sure that this file exists. Otherwise, SDK locator, it's a class from the internal implementation, will fail, and you won't be able to build it. So the thing you need to learn out of this, whenever you have a full run something like assemble debug, you're messing with resources, make sure that these local properties files exist, and this would be the snippet that will simply look up in your system environment. First guess failed, it will try guess it through Android SDK route. And third guess would be just simply looking in your home folder. Do we have still time? Okay. Just briefly mention it. It's kind of complex topics on its own. I wanted to bring it. I knew that I mostly won't made on time on that. But if someone is interested in covering this stuff, getting the real numbers of what actually get tested, I will be here around, so I can show you directly the code. The long story short, Gradle TestKit is a separate process. Running tests is separate process. Any instrumentation tool cannot simply perform cross-process communication. And to solve this problem, we are instrumenting our code with additional code coverage probes. It's essentially Boolean facts. Is this line of code has been executed or not? And then we are cross-communicating with a standalone agent by dumping everything into one file. Again, very complex, sounds too much technical details, I understand. But if you're interested, we can go briefly from it. As a conclusions, testing is not that hard. You simply scaffold a real test project. Well, not real in the sense what you would expect, but those cases that you support from your plugin perspective. If you're publishing, avoid using with plugin class path method, and parameterize across Gradle, Android Gradle plugin combo, because things can be very unpredictable, especially with the release cadence that frequent. And be a good citizen, also ensure that you test different features of Gradle, such as configuration cache. It would be as simple as passing yet another parameter to your test. And you can parameterize it with GUnit 5 to any extent as you want. You're not limited to GUnit 5. You can use ngUnit, you can use Spock, whatever framework you like. The main takeover, you would do all the testing over the scaffold project and use Gradle TestKit and GradleRunner to perform this action activity. So feel free to get in touch if you want, and this presentation could be found there as well.